Hello, developers! Welcome to another exciting journey into the world of design patterns. In today's video, we're going to explore the chain of responsibility design pattern in Java. This pattern is a powerful way to pass a request along a chain of handlers, allowing for a flexible and decoupled way to process that request. Let's dive in. Before we jump into the intricacies of the chain of responsibility, let's understand the problem it solves. In many applications, there are scenarios where multiple objects may handle a request, but the specific handler isn't known until runtime. The chain of responsibility addresses this by allowing a chain of handlers to collaboratively process the request without the sender needing to know the exact handler. Now, let's take a look at the UML diagram for the chain of responsibility. We have a chain of handler objects, each with a handle request method. The request is passed through the chain until a handler can successfully process it. This structure promotes flexibility and extensibility in our code. Breaking down the UML, we can see how each handler has a reference to the next handler in the chain. When a request comes in, the first handler attempts to process it. If it can't, it delegates the request to the next handler in line. This continues until a handler successfully processes the request or the end of the chain is reached. To illustrate this pattern, let's consider a real-world scenario. Imagine an expense approval system where requests need to pass through different levels of authorization. We have three concrete handlers representing a manager, director, and CEO. Each handler has a maximum approval limit. If the expense amount is within the handler's limit, it approves the expense, otherwise, it passes the request to the next handler in the chain. I'll now walk you through a code example demonstrating how we can implement the chain of responsibility in Java to handle these expense requests dynamically. The client code creates the chain and tests it with different expense requests. The output should demonstrate how the expenses are approved or denied based on the chain of responsibility. Now that we've seen the chain of responsibility in action, let's discuss its advantages. This pattern promotes loose coupling, making it easy to modify the chain or add new handlers without affecting the client code. It also allows for a more dynamic and runtime determination of the responsible handler. However, like any pattern, there are pitfalls to be aware of. It's crucial to ensure that every request gets handled in the chain. Otherwise, it might lead to unexpected behavior. Additionally, the order of the handlers in the chain is crucial, and a poorly designed chain may result in some handlers being skipped. In conclusion, the chain of responsibility design pattern provides an elegant solution to handle requests in a flexible and decoupled manner. We've explored its UML, seen a practical example, and discussed both its advantages and potential pitfalls. Now, armed with this knowledge, you can leverage the chain of responsibility to enhance the design of your Java applications.